One of the first insights we learned in this class, and the one that stick with me the most, was what a real-time system is and what real-time means. Going into the class, I thought, oh, real-time system, maybe we're going to make something that goes really fast and has great average performance. But that's not at all what this class is or what a real-time system is. What it is it guarantees that your tasks are going to meet deadlines. So your system is predictable. It's always going to do what it needs to do within a certain deadline, which is very different than running fast. We don't care about performance. We don't care if the system can process data really, really fast. What we care about mostly is that it meets deadlines. And if it does not meet a deadline, then that can cause many different things. For example, there's a hard deadline. This would cause catastrophic failure within the system. You would not be able to use the system afterwards. All the data would be irrelevant, and it could cause, for example, a ship to blow up because it didn't meet a deadline. Something fuses, it's done. Where that's very different than a soft deadline, which can be seen through watching YouTube. If your internet goes out a little bit, your video might buffer or your quality might get a little worse, and that's because the website is not meeting its deadline and nothing bad happens. You can still watch the video, you can still use YouTube, but you're just going to have degraded performance, and that's what missing a soft deadline looks like. Now, a challenge that I encountered in this class, not even really related to real-time systems, but it was setting up VS Code for the walkway simulator. This took me probably around 2 or 3 hours to do. Dr. Mike set up a video to watch. I watched the tutorial and I was doing everything correctly, but I kept getting errors, and the walkway diagram wouldn't pop up. So what I did to tackle this was I first looked up YouTube videos myself of other people setting it up. That didn't really work because they were basically doing the same thing as Dr. Mike. So I then used AI and gave it the error prompts and asked, what could be going wrong here? And it helped me for a good while until I reached a wall that I could not solve. So then I used Yellow Dig, and I saw that similar people encountered the same problem. And the issue that after everything was just the name of my desktop's folder. It had a space in it, and I needed to not have a space in it. So I debugged a lot of it using AI, and the final thing that I needed to debug, I used my community, the Yellow Dig community, to solve it. If that did not work, I would have gone to office hours and tried to figure it out. And worst case scenario, I would have used the online simulator. But I'm familiar with VS Code, and I wanted to use that for this semester. Finally, a real-world application for this class. Dr. Mike said at the beginning of the year that we would be using an ESP32 in senior design. So this class, being able to do 6 applications of using the board, programming it using free RTOS, will be very useful for any project that I could do for my senior design. For example, if I have a robot of some sort, my application 6 I created a conveyor belt simulator, which just uses an ultrasonic sensor to track where items are. And this could be useful for the robot because I don't want it to get too close to a wall and crash into something. So it can have a ultrasonic sensor on it, and if it detects something, it can stop automatically using the ISRs and those other tasks that we learned about in class. And also, I can use the sensor to track other things and reliably sample data in certain milliseconds and meet deadlines. So this class was very useful for that, and I now know I have a good prerequisition for senior design, and I'm grateful for that. It also taught me how to use AI in a correct way and how to document it, which could be useful in the workforce when they all have their own AI software that we have to use rather than ChatGPT.